well, could you tell us a little bit about this fantastic 833 transmitter you have here?
Alrighty, from about here up is the RF 833s and push-pull parallel, in parallel.
See if we can look inside.
And if you can see in there, this is the grid compartment over here. This is the plate output compartment. And, down below is a 4E27 driver.
Oh wow, that is very nice. Right on the door. Talk about ease of troubleshooting. Holy smokes, look at that, folks. Oh, that is fantastic. Is that the 20-meter tank coil right there? Plate coil?
Right. This is
and that couples that couples to the
couples to a link right back in the back.
Oh, for heaven's sake! So you close the door and you got.
To the grid.
Oh, well, that's fantastic.
And the modulators, the 833 modulators, are in the back in here.
Oh wow!
With the cycle autoformer running from here up over to this edge.
And as you described that thing before, instead of a modulation transformer where you have a primary and secondary winding, this thing has just a big winding with taps on it.
Just a single winding.
A regular auto transformer.
Right.
And you were saying that there, high-level modulation usage, they're actually more efficient than a regular modulation transformer.
That's what I read in the literature.
Huh, very interesting.
Of course, we've got the variac to change the B-class and variac for the filaments. With circuit breakers, that'll kick out if they get a short or overload on them.
And what power level do you generally run this at?
About 2,800 volts at about 330 mils.
Which is about...
it's about 900 watts.
900 watts. Yeah, that's fantastic. Now, in addition...
I can go on up. I can load it up and get a kilowatt output easy enough.
With no problem.
Right.
Well, the Gates 1 kilowatt transmitter for many years was built around a pair of 833s, was it not?
I leave the RF down a little bit and then crank up with the audio so that on peaks it stays within the input limits.
And you were using control, what term is that? Not also modulation, but...
it's negative cycle loading.
Negative cycle loading. Would you give us a small explanation of what goes on there in just a few words without looking at a...
Well, the negative cycle loading is the process by which when the audio goes through zero in the negative direction, a load resistor is switched in across the modulator so that we don't develop as much audio voltage. But on the positive swing, when the audio swings through zero and goes positive, the load is proper for the modulator and you get maximum audio output. Therefore, you get a maximum swing in the RF output.
Very interesting. Very interesting.
And the beauty part of it is that when the audio goes through zero, there's no transients developed. Because all the switching is done at zero audio voltage.
While in the so-called ultramodulation scheme, was it not true that they had to use a type of filter to get rid of the square waves?
If you use high-level clipping,
yeah,
then you would have to have additional filtering and additional losses.
Yeah.
In the RF.
Do you feel there are advantages using of high-level the high-level type of limiting circuits as opposed to low-level? Do you think there's any difference? You accomplish the same thing, but with better efficiency at the high level, or you have any opinions on that?
I think it's done better at the high level. Because if you do it at the low level, then it tends to reach a balance in the audio components, and then you don't get the maximum swing in one direction.
So you may start out at a very low level with asymmetry, but because of the audio components, transformers, or whatever, it becomes symmetrical again by the time it gets to the driver transformer or a high-level stage, I guess.
This is correct.
Very interesting.
And you end up with one side of the audio that is compressed and the other side is not, but you hit a zero reference that's in the middle, so you don't get a maximum swing
When
on one direction.
Norm looks at this tape, perhaps Norm would probably like to discuss that further with you, not on a rebuttal, but on his opinion and what he's doing at the low level area.
Well, you definitely can improve your signal by doing it at low
Linearity,
level.
overall linearity, yes.
And keeping the polarization correct so that
Get rid of half power problems with modulation transformers and all that.
Yeah.
But on the other hand, On the other hand, it's not as efficient.
I don't believe it's as efficient as otherwise.
Yeah.
Well, we're still here. Yeah.